Okay, today we're going to look at how to graph quadratics, and standard form. If you look at the notes, the standard form of a quadratic function or quadratic equation is y is equal to ax squared plus bx plus c, where a is not equal to 0. A could be 1 or 2 or 3 or 1/2 or -10, but can't be 0. So from what you can tell from the standard form of quadratic, there's going to be an x squared term, there's going to be an x term, there's going to be a c term. An example of this would be like y is equal to 2x squared plus 5x plus 6. That would be an example of a quadratic. Oh, it's a little big there. Y is equal to 2x squared plus 5x plus 6. The key thing that makes it quadratic is this x squared term at the beginning. The graph of a quadratic is a U-shaped curve called a parabola. It looks like this. It is symmetrical on both sides, even though it doesn't look it when I drew it. It is symmetrical on both sides, and it's symmetrical about this low point here. This low point is called the vertex. So the left and right side of the vertex looks identical when you graph a quadratic. Alright, let's take a look at how you would actually graph. Ooh, fancy. Alright, so here are all the steps you need to take in order to graph a parabola. First you look at the a term, which is the coefficient of the x squared. And if the coefficient of the x squared, the a, is greater than 0, then the parabola opens upward like a U. If it opens up like this, and if the a value is less than 0 or a negative number, then it's going to open downwards like this. Alright, after you have determined whether it opens up or down, you will find the x-coordinate of the vertex, which is that low point in this case, or the high point if it opens down. Find the x-coordinate of the vertex by using this equation. This equation will give you the x-coordinate of the vertex. X is equal to -b divided by 2 times a. So that would be the b, that's the coefficient of the x term, divided by 2 times a. A is the coefficient of the x squared term. And then you will substitute that x-coordinate into the equation to find the y-coordinate, or the vertex, for the vertex. And then you'll have the ordered pair for the vertex. The equation for the axis of symmetry, is, it goes through the vertex. It's a straight line. It's the line where the parabola is cut in half. The axis of symmetry is the axis where it's symmetrical, or the line that goes through the vertex cuts it in half. And the equation for that is the same as the way that you find the x-coordinate of the vertex. X equals -b divided by 2a. But in this case, it's the equation of a line. The coordinates for the y-intercept are 0, c. C is the constant term. At the very end is the constant term. So the coordinates of the y-intercept are 0, c. The maximum or minimum is the y-coordinate of the vertex. Okay, so if it opens down, then it will have a maximum, which is the y-coordinate of the vertex. And if it opens up, it will have a minimum point, which is the y-coordinate of the vertex. You will reflect the y-intercept over the axis of symmetry to get a point on the other side of the vertex, or on the other side of the axis of symmetry. And then you'll sketch your graph. You'll have a vertex, a y-intercept, and a reflected point on the other side from the y-intercept. And then you state your domain and range. We'll look at that in just a second. Alright, so let's look at how exactly this works. Alright, So first we determine whether we want to look at the a, b, and c values. They are very important. A is the coefficient of x squared, it's 1. B is the coefficient of x, it's -4. And c is the constant, which isn't there, so it's 0. Alright, so since a is -1, this opens up. We now need to find the vertex. So to find the x-coordinate of the vertex, we use the equation x is equal to, this is also going to be the axis of symmetry, -b/2a. So in this case, b is -4, so -b would be 4, and then 2 times a, 2 times 1, would be 2. So x is equal to 2. What that gives us is the x-coordinate of the vertex, and it also gives us the axis of symmetry, x is equal to 2. Okay? So what that means is if we look at our graph will be reflected across the line x is equal to 2, which is a vertical line that goes through 2 on the x-axis. Okay, so if we keep this line in mind, then we will know that it should be a U-shape that's reflected across this line. We have the x-coordinate of the vertex. The vertex is going to be somewhere on this dotted line, but we don't have the y-coordinate. So what we're going to do is we're going to substitute the x-coordinate into the equation to find the y-coordinate. So it'd be 2 squared instead of x squared minus 4 times 2 instead of 4 times x, which would be 4 minus 8, which would be -4. So the y-coordinate of the vertex is -4. So I'm going to go ahead and plot that vertex to -4 right here. So that's the vertex. Since this opens up, that will be a minimum value. Alright, now we need to look for the y-intercept. The y-intercept is 0, c, whatever the c value is. And in this case, the c value is 0. So it's 0, 0 is the y-intercept. So that's right here. And what we're going to do is we're going to take that point and reflect it over this dotted line. So it's 2 spaces away from the dotted line. So on the other side, it will be 2 spaces away from the dotted line. And with these 3 points, I can now make my parabola. Let's go with teal. So, whoops, I missed it. So it's going to be a U-shaped. It's a little difficult to draw with the stylus here, but it's going to be a U-shaped like this. I still messed this side up. There we go. I'm going to U-shape. Mine kind of looks like a V, and that's okay, but it really should be a U. It shouldn't have a hard stop here. It should be a U. If we look at the domain is all the possible x values, so look for how far left the graph the parabola goes and how far right the parabola goes. And we can see it goes on forever to the left, forever to the right. So we would say that the domain is -infinity to infinity. The range, however, even though it goes, you can see the arrows, they go all the way up, there's no arrows pointing down. Alright, the furthest down that this thing goes is to -4. So the smallest is -4, but it does go all the way up. So it's -4 to infinity. Those are all the possible y values for this equation right here. Alright, and that is how we graph our parabolas. So let's look at another one. Y is equal to -x squared plus 6x minus 8. Let's identify our A, B, and C. A is -1, B is 6, C is -8. Opens down because A is negative, which means that the vertex, whatever it is going to be a maximum value. Okay, so the vertex, the x-coordinate of the vertex and the axis of symmetry is going to be negative b over 2a. B is 6, so negative 6 over 2 times a is negative 1, so negative 2. So 3. So the x-coordinate of the vertex is 3, the axis of symmetry is the dotted line, x equals 3. So I'm going to graph that line. It is a vertical line that goes through 3. And my vertex is going to be somewhere on there. I'm just not 100% sure where on there. I have to plug it into this equation to figure out where it's going to be. So to do that, I'm going to need a little bit of room. So my equation, y is equal to negative x squared, and x is 3, so negative 3 squared plus 6 times 3 minus 8. So that's negative 9, 3 squared is 9, plus 18 minus 8. Negative 9 plus 18 is 9. 9 minus 8 is 1. So the y-coordinate is 1. So I'm looking at a vertex right here at 3, 1. The y-intercept is the c value, which in this case is negative 8. So 0, negative 8, which is down here. So I'm going to reflect that to get my other point. So it's 1, 2, 3 away, so 1, 2, 3 away on the other side. I'm going to connect these to make my graph. So curved, it's a U, upside down U. And then curved on the other side, maybe. Up, turns around. Trying to make this like curved. It's supposed to be curved. This is very hard to do. Okay, so the domain always going to be the same because these will always go left and right indefinitely. It's going to be negative infinity to infinity. However, the range, instead of going up from negative 4 like last time, it's going down from 1. So the smallest is negative infinity. We can see it goes all the way down to negative infinity, and the largest y value is up here at 1, and that includes 1, so we use a bracket. We have our graph, we have all of our information. We're good here. Okay, so once again, identify our A, 2, our B is 8, and our C is 7. This opens up because A is 2. The vertex and axis of symmetry will be negative B over 2A. So negative 8 over 4, which is negative 2. So the x-coordinate is negative 2. The axis of symmetry is negative 2. So we're going to draw our dotted line at negative 2. And then, now that I found the axis of symmetry, I'm going to get rid of this because now I need to use the equation and my x-coordinate to find my y-coordinate. So y is equal to 2 negative 2 squared plus 8 times negative 2 plus 7. So 2 times 4, negative 2 squared is 4, minus 16 plus 7. So 8 minus 16, what? 4, 8. Okay, so 8 minus 16, negative 8 plus 7, which is -1. So my y-coordinate is -1, so my vertex is down here at -1. Remember, this opens up, so we will have a minimum at the vertex. The vertex will be a minimum point. The y-intercept is the c value, which in this case is 7, so we'll have 0, 7. So I'm going to graph that. It's right here. And then I'll reflect it to get another point. So 1, 2, 1, 2. And then I can connect these to make my parabola. These are getting a little bit better, but not really. So something like this would be my parabola. The domain of this would be, as usual, -infinity to infinity. That's the same for all of them. And maybe I will draw that a little bit better so you can actually see that it's an infinity symbol. So -infinity to infinity. And then the range, the lowest point is right here at -1, and the highest point, it goes up forever, so it's infinity. So -1 to infinity, including -1, because that is included there. Okay, that's all for this lesson. Thanks for joining me.